Okay. How's my voice? Can you hear me? Okay. What about you? Everything's okay? Okay, hello everybody. Welcome to the live stream channel. During the 3 days, we will be together with number theory. Let me tell you something about these lessons. From Tuesday to Thursday, the time remains same from 11 to 12:50. And during my explanations, if you have any problem, please take your notes and keep it. When we finish the lesson, you can text me. So the next day I will try to respond your questions logically at first at 5 minutes before start the new section, new part. After each solution, I will give you a time to write it. And last but not least, please be on time. Take your responsibilities. Because as you know, there is a saying that there is no shortcut and an elevator to success. From now, I wish you every happiness and success. So what we are waiting for, let's begin. Okay, we will start first with the basic properties. Okay, A is divisibility. A is equal to B times Q, means when we multiply B and Q, we will get A. So here we can say A is divisible by B, which B is not equal to 0. Q is an integer, and Q divides both A and B. A, B, C, D, M, and N integers, and P, Q primes. So first, we say that every number divisible by itself, N is divisible by N. And 2, if A divides B and B divides C, automatically we can say C is divisible by A, or A divides C. And the third, when D divides N and D divides M, then D divides A plus B and Y, because if N is divisible by D, when we multiply N by any number, also AN is divisible by D. And we can do the same thing for M. When we multiply M by any number, let's say by B, BM is also divisible by D. So when we take the sum of AN and BM, D divides AN plus BM. And therefore, 1 divides any number and N divides 0. Any number divides 0. In this part, I'm going to show you how to convert division algorithm to modular arithmetic system and how to use it. I will start first with the division algorithm. 3 to the power of 4 is divided by 5. 5 goes 3 to the power of 4 16 times. And here is 1 left over. So when we convert this division algorithm to modular arithmetic system, 3 to the power of 4 is congruent 1 in mod 5. Means that when we divide 3 to the power of 4 by 5, 1 is remainder, 1 is a leftover. For example, 27 is congruent x in mod 6. When we divide 27 by 6, 27 is equal to 6 goes 27 4 times, 4 times 6, plus 3 here is remainder. So automatically we got the solution. Glad to have it. So 27 is congruent 3 in mod 6. Okay? As a title, convert division algorithm to modular arithmetic. Okay, please write it. Actually, I sent you this lesson by your teachers 2 days ago. And I will do the same thing for tomorrow and the day after tomorrow. By the way, you can arrange, absorb, and think the lesson. And otherwise, it can be difficult to understand it, And please rewatch this lesson completely later. I think it doesn't a serious drawback. How is my quality of voice and view? Okay. Oliver, welcome to the lesson. When you finish to write, please just write go. Okay? Okay, Flamber, thank you. You are in hurry. Okay. So let's keep going. And in this part, we will talk about Fermat's little theorem and Fermat's theorem. We have some conditions here, such as if p is a prime number, such that a is not divisible by p, then in modular arithmetic system, a to the power of p minus 1 is congruent 1 in mod p. Let me write it first. The 7. P is a prime. And A is not divisible by P. So in this case, we can say A to the power of P minus 1 is congruent 1 in mod P. For example, as a prime, I will take 5. So for A, let's take 3, because 5 is not divisible by 3. 3 to the power of 5 minus 1. What is here the remainder? It's 3 to the power of 4. When we divide 3 to the power of 4 by 5, as you know, we will get here as 1, right? Okay. It is Fermat Little theorem. And the second, Fermat's theorem, for any integer a and p is prime, we have a to the power of p is congruent a in mod p. So p is prime, and likewise a is not divisible by p. So we say a to the power of p is congruent a in mod p. For example, 3 to the power of 5 is congruent in mod 5. What is here the remainder? Remainder is 3, right? 3 is a leftover. Okay, please write it. Fermat's theorem. I want to hear the word go. Okay. Let's move on. We'll continue with the 9.1. If a over b is irreducible, a over b is reducible means that we cannot simplify a and b. So it can't be simplified. If a and b is irreducible, greatest common factor of a and b is 1. And they will have special name. They are called relatively prime numbers. A and b relatively prime numbers. For example, greatest common factor 4 and 9. 4 over 9. We can simplify it? No. Why? Because when we find here greatest common factor 4 and 9, we will get is 1. Because they are relatively prime numbers. 3 over 7 is the same. Greatest common factor of 3 and 7 is also 1. And the next property says one of 3 consecutive numbers is divisible by 3. So if for n minus 1, n, and n plus 1. These numbers are three consecutive numbers. For example, 7, 8, 9. 9, 10, 11. Can you tell me another three consecutive number? Thank you. 21, 22, 23. And the property says one of three consecutive numbers is divisible by 3. So here is 9, and here is 21 is divisible by 3. Okay, please write 9 and 10. Okay. And I forgot to tell you, also you can write here as the A. Let me show you that. From here, from A is divisibility, till Fermat little theorem. So 1, 2, 3, 4, and 5. Okay. Okay, please a bit hurry. Okay. Oliver go, Eva go, Kiki go, Eva go. And the others? Flomer go. Maria go. Blagoy go. Blagoy, your profile picture is a bit different. It seems a bit horror. Okay. So in this episode, I want you to do something as well. We'll start to solve the problems. The first and fifth time, I will let you solve it. After that, we are gonna decide how to approach it. Okay? The first question. Show that a minus c divides ab plus cd. Then we have to prove a minus c divides ad plus bc as well. One or 2 minutes, think and absorb it. Is there anybody idea? In division algorithm, if I will say a is divisible by k and b is divisible by k, we can say that a plus b and a minus b also divisible by k. Do you agree with that? We will use this property to solve this problem. So in this case, AB plus CD is divisible by A minus C. And if A minus C divides AD plus BC, when we take difference between AB plus CD and AD plus BC, also the difference must be divisible by A minus C. Like here, look, A minus C is divisible by K. Now if when we take difference between AB plus CD and AD plus BC, if the new expression is divisible by A minus C, so automatically A minus C divides AD plus BC. Let's do this. A minus C divides, I am taking difference, AB plus CD minus AD plus BC. So A minus C divides AB plus CD minus AD minus BC. And A minus C divides, we'll make a group AB and AD, CD and BC. A times B minus D minus C times B minus D, which is A minus C divides A minus C times B minus D, the common factor. This expression is divisible by A minus C, so automatically A minus C also divides AD plus BC. Okay. You can write it down. Did you understand it? Do you have any question here? I think it's a very simple and basic example in number theory. Everything is all right? My cat. Sometimes I'm really so tired to feeding my cat. Maya, let's go. And the others, everything is okay? Can you see and hear? Give me the response. Okay. Okay, thank you. The others? Orhan, yes. Blaja, yes. Zehra, yes. Maria, yes. Angela, yes. Nino, yes. Eva, yes. Okay. Thank you very much, guys. Thank you very much, everybody, actually. Can I clean it for the next question? Okay. Okay. Matej says go. Okay, Matej. I will. In hurry. Okay, let me clean it. And the second question. Prove that for any integer n. Prove that for any integer n. 30 divides n to the power of 5 minus n. Okay. Think about this. How can we figure out n to the power of 5 minus n is divisible by 30, and we have to prove n is an integer. How should our approach be? To find it, actually, first we have to find prime factorization of 30. What is prime factorization of 30? 2, 3, and 5, right? Yes. So we can say 1. 2 divides n to the power of 5 minus n. 2. 3 divides n to the power of 5 minus n. And the third, 5 divides n to the power of 5 minus n. Okay. We have to solve each case here. When we prove each case, so automatically n to the power of 5 minus n for any integer is divisible by number 30. How can we prove that? N to the power of 5 minus n is divisible by 2. Thank you very much, Mr. Rejaya. Welcome to the lesson. Okay. When we solve it, actually, we will use Fermat's little theorem and Fermat theorem. We will apply. So let me show you how can we do this. Remember first, when we convert division algorithm to modular arithmetic system, so I will convert n to the power of 5 minus n is divided by 2. How can we convert it? N to the power of 5 minus n is congruent in mod 2. The first case. If n to the power of 5 minus n is divisible by 2, what is remainder? Remainder is 0, right? We have to get here a 0. So, n to the power of 5 minus n is congruent 0 in mod 2. We have to prove that. Instead of n to the power of 5, I will write n squared to the power of 2 times n. Minus n is congruent 0 in mod 2. Here we will apply Fermat theorem. Remember that a to the power of p is congruent a in mod p. So look at it. A to the power of 2 in mod 2. What is remainder? A. So remainder will be here, n squared. So n squared times n minus n is congruent 0 in mod 2. And in this part also we will apply Fermat theorem. A to the power of p is congruent a in mod p. Fermat theorem. So n squared is congruent in mod 2. What is it? Will be itself n. N times n minus n is congruent 0 in mod 2. n times n is n square minus n is congruent 0 in mod 2, same. N square in mod 2 Fermat theorem will be itself of the number is n minus n is congruent 0 in mod 2, n minus n is 0 is congruent 0 in mod 2. By the way, we proved the first case. So for any integer n to the power of 5 minus n is divisible by 2 by using just Fermat theorem. And the second case, don't write please, just listen to me and after that I will give you time to write it. Learning is nothing but understanding world around us, you know. So the second case, n to the power of 5 minus n is divisible by 3, converts to modular arithmetic system. N to the power of 5 minus n is congruent 0 mod 3. N squared to the power of 2 times n minus n is congruent 0 in mod 3. We will apply here and not Fermat theorem. We will apply Fermat's little theorem. Remember Fermat's little theorem. What is it? A to the power of p minus 1 is congruent. 1 is left over in mod p. The same. A to the power of 2 is congruent in mod 3. What is it? A square is congruent in mod 3. Tell me the remainder. The remainder is 1. 1 times n minus n is congruent 0 in mod 3. 1 times n is itself. N minus n is congruent 0 in mod 3. So by the way, we will get 0 is congruent 0 in mod 3. Glad to have it. And the third one is for you. At home. I want you to solve it. Okay, please write it. Okay, I will repeat. No problem. You don't need to pay anything for that. Just relax. Stay calm. First write and after that I will explain, okay? Recai Bey, sesim ve görüntüm nasıl, iyi mi? Thank you. Great. Nazar değmez inşallah. I have a good internet connection for now. And I hope it goes till the end of the lesson. Yes. We have to study a lot to get success. In today's world, it works like that, unfortunately. Hardworking. There's no shortcut and an elevator to success. We have to take our responsibilities and we have to do our best. Do you have any schedule for study? Almost 2 weeks passed in winter holiday. What have you done during the winter holiday? At least you will study 2 or 3 hours for every single day. Because these competitions are very important for your future life. When you get a certificate in these competitions, you can use these certificates to go abroad to study. So there are many good competitors. So you have to practice, exercise a lot. You have much to learn, actually. Dostacı söyler Recep Bey, değil mi? Okay, for the second case, coming for Blagoice, horror man. Okay, n to the power of 5 minus n is congruent 0 in mod 3, so instead of n to the power of 5, we can write n squared to the power of 2 times n. Will give us n to the power of 5. According to Fermat-Little's theorem, a to the power of p minus 1 is congruent 1 in mod p. We have is 3, prime number, and we have is 2. 3, 2, p minus 1. 3 minus 1 will give us 2. So we can use here Fermat's little theorem. The Fermat's little theorem says, in this case, the remainder is always 1. So n squared to the power of 2. Instead of n squared, we can write a, any number. A squared in mod 3, what is it? 1. 1 times n minus n. And 1 times n is itself n minus n. 0. 0 is congruent 0 in mod 3. Okay, Blagoice? No problem. Okay, everybody, can I clean it? Okay. Flammer, yes. Kiki, yes. Flammer, I think you are the fastest guy. Blagoice, yes. And the others, they are still riding, I think. Orhan. Orhan Baba, yes. No problem, Flammer. You're welcome. Don't mention it. Maria, yes. Eva, yes. Angela, yes. Eva, yes. Nino, yes. Blage. Yes. Misrata? Yes. Okay, clean it. The third question is coming. Find the 3-digit numbers ABC 4, ABC is divided by C equals BC. ABC is 3, BC 2-digit numbers. Okay. We have to find all values for A, B, and C. Okay, please think about this, observe it. How should our approach be? How can we figure out? Try to do something, please, briefly. And let me take a cup of tea. Okay. 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 Can you hear me? Actually, we have two ways to solve it. I want to show you both ways, and after that we will decide which way is better than the other. Okay. The first way. Three-digit number ABC. It is 100A plus 10B plus C over C is equal to 10B plus C, right? Cross production 100A plus 10B plus C is equal to 10B times C plus C times C squared. 10B times C plus C squared. When we simplify it, let's isolate 100A. We will get 10B plus C times C minus 1. Take both 10B and C to the other side. So we will get 10B plus C times C minus 1. I simplify it actually. What is the meaning of 100A? For example, for A is 2. 100 times 2, 200. For A is 3, 300. Right? Yes, it's a 3-digit number, I know it. Instead of 100A, can we write A 0, 0? Because for A is 2, 100 times 2 is 200. Is equal to 10B plus C times C minus 1. Yes. We have double zeros. double. 10b. For any number for b, 10b. When you look at the number of 10b, the last digit will be always 0, right? For b is 5. 10 times 5, 50. Look at the last digit, 0. For b is 8. 10 times 8, 80, 0. For b is 15. 10 times 15, 150. 15, b. Can be? B can be 15? Can you hear me? B can be 15 or not? No, why? Because A, B, and C must be less than 10, right? Bravos. So A, B, C less than or equal to 9, or yes, Blakovic, A, B, C is less than 10. Is a digit. You're right, thank you. So the 1, 0 will be from here. And the another 0 we have to get from C and C minus 1. How can we do this? C can be 5. 5 minus 1 is 4. 5 times 4, 20. The last digit 0, yes. Another possibilities for C is 6. 6 minus 1 is 5. 6 times 5, 30. Yes, the last digit is 0. So for C is 5. And for 6, we will try to solve it. First start with 5. For C is 5. For C is 5. A 0, 0 is equal to 5, 0 plus 5 times 4. Actually, instead of 10 times b, we can write b0. Likewise, 100 times a is a0, 0. 10 times b is b0 plus 5. 4 and a0, 0 cancels each other. We will get 25. A is equal to b0 plus 5. So a is 1, b is 2. I got first ABC. What is it? 125. Because for C is 5, A is 1 and B is 2. 1, 2 and 5. 125. For C is 6. We will get for A is 3. For B is 7. So the another ABC 375. Okay. When you solve it, you have to prove arkadaşlar. 125 is divisible by 5. What is it? 25. Yes. Will give us less 2 digit. 375 is divisible by 5. What is answer? 75. Less 2 digit. Okay, write it, and after that I will show you the second way. Oh, sorry, we have a mistake here. Yes, you are right. So for 6 is... Okay, I am coming. We have a mistake here. Wait a second. So it means that for C is 5, we have two solutions for A and B. I'm sorry, it's my mistake. It's my mistake. We will get here two different A and B. The first is 1 and 2. And the second is A is 3. 25 times 3 is 75. And B is 7. Yes. For C is 6. That's a contradiction. Yes, you're right. So 125 and 375. That's a contradiction. Okay, write it, and after that I will explain. I will clear it. Thank you, Nino. I missed it. Blaže 376. Yes, thank you, Blaže. Okay. How can we get 5? Teacher, can you repeat that part? How do we know that C is 5? Okay. As I told you, please write to finish. Okay. 100 times A. The value of this number depends on the value of A. A is defines the value of 100 times A. For example, for A is 2, 100 times 2 is 200. For A is 3, 300. For A is 5, 500. So instead of 100 times A, we can write A 0, 0. The last two digits is 0, double. And 10B, same. The last digit will be here is 0 of 10B for any value that less than 10. The 1 0 will be from here, and we have to get the second 0 from C and C minus 1. So for C is 5, C minus 1 is 4, 5 times 4 is 20, last digit is 0. For C is 5, 5 minus 1 is 5, 6 times 5 is 30, and the last digit is 0. So for C is, there are two possibilities, 5 or 6. For C is 5, A 0, 0 is equal to, when we write instead of 100 times A is A 0, 0, instead of 10 times B, we can write B 0. Likewise. So B 0 plus, for C is 5, 5 times 5 minus 1 is 4. A 0, 0 and 4 simplify. 25 times A is equal to B0 plus 5. So here we will try to find all possibilities. For A is 1, 25 times 1 is 25, B is 2, 20 plus 5 is 25. For A is 3, 25 times 3 is 75. For B is 7, 70 plus 5 is, which is 75. Okay, can I clean it? Because I want to show you the second way. Okay. Maria, yes. Kiki, yes. Others? Okay. Orhan Baba, yes. Oliver, yes. Eva, yes. Okay. Oh, sorry. The second way is more practical. Anyway, let me clean everything here. I don't need a space, but... Okay, the second way. ABC divided by C is BC. Means C times C will give us C. Right? When we multiply BC and C, we will get ABC. C times C will give us C. C times C will give us again itself. I mean that. So there are just three possibilities for C. C is elemental 1, 3, no 1, 5 and 6. Because 1 times 1, again 1, 5 times 5 is 5, and 6 times 6 is, again 6, 36. The last digit is 6. 5 and 1. There are three possibilities for C. 1, 5 and 6. And after that, for C is 1, no solution. For A and B, you can check it. For C is 5. We will get for A is 1, for B is 2, and for A is 3, and for B is 7. Practical way. So what do you say? Which way is better than the other one? First or second? The second way, yes. Second. So we can say the second way has proved that more useful. For CS6, we don't have any solution. Because A, B, and C must be natural number that's less than 10. So for C is 6, we can get the fractions for A and B. For CS6, I want you to solve it. Okay, let's look at the next example. Can we continue? Let's move on. At least I can write the question here. We don't need it. Okay, question 4. Prove that for every positive integer n, for every positive integer n, the expression 7 times 5 to the power of 2n plus 12 times 6 to the power of n is divisible by 19. Okay. Is there anybody idea for that? I want to hear something by you. Okay, let's start it. Pay attention. 19 divides 7 times 5 to the power of 2n is 25 to the power of n, right? Plus 12 times 6n. Separated. So 19 divides 7 times 25 to the power of 10, 25 to the power of n. Instead of 12 times 6 to the power of n, we write 19 times 6 to the power of n minus 7 times 6 to the power of n. And after that, 19 divides, we will make a group between 7 times 25 to the power of n and minus 7 times 6 to the power of n plus 19 times 6 to the power of n. 7 common factor. So 19 divides 7 times 25 to the power of n minus 6 to the power of n plus 19 times 6 to the power of n. And remember, a to the power of n minus b to the power of n. What is it? A minus b times, let's say, k, right? And a to the power of n plus b to the power of n is a plus b times, let's say, l. We will do the same thing. So 19 divides 7 times 25 to the power of n minus 6 to the power of n. 25 minus 6 times, let's say, k. And plus 19 times 6 to the power of n. And 19 divides 7 times 19 times k plus 19 times 6 to the power of n. Another common factor, what is it? 19. 19 divides 19 times 7k plus 6 to the power of n. So automatically 7 times 5 to the power of 2n plus 12 times 6 to the power of n is divisible by 19 for every positive integer n. Okay. Copy it, please. For example, if n is negative, for example, negative 1. 6 to the power of negative 1, what is it? 1 over 6 is the fraction. How can we provide the number that divisible by 19? Because of that, we have to use for n is positive integer. Okay? Did you understand? I think everything is obvious here. Okay. Can we continue? Okay. So then let's go. Okay, question 5. For question 5, we have a history. And story finds all 3-digit numbers whose digits are different than 0, and the sum of all different two-digit numbers composed of the digits of these numbers are equal to that number. Let me read the question loudly. Find all 3-digit numbers whose digits are different than 0, and the sum of all different 2-digit numbers composed of the digits of these numbers are equal to that number. Did you understand something from the question? Exactly. Spot on. Spot on, Blaži. Thank you. Yes. AB plus AC plus BC plus BA plus CA plus CB will give us ABC. Yes. So when we open it, 10A plus B plus 10A plus C plus 10B plus C plus 10B plus A plus 10C plus A plus 10C plus B is equal to 100A plus 10B plus C. So we will get here as 22 times A plus B plus C is equal to 100A plus 10B and C. When we simplify it, we will get 78A, which is 12B plus 21C divided by 3 both. 26A is equal to 4B plus 7C we will get. And we can say it's important. Aware of it. What is that? Maximum. Maximum. Maximum value of 4b plus 7c is, let's say for b and c, take the greatest digit. What is it? 9. 4 times 9 plus 7 times 9, which is 99. Then 26a is less than or equal to 99. So a must be less than or equal to 3. We got it. It's important. A must be less than or equal to 3. So 3 possibilities. We have to find each case. For A is 1. For A is 1. 26 for A is 1. 26 is equal to 4b plus 7c. And from here we will get 4c is 2, 4b is 3. 4a is 2, 4a is 3. Tell me the answer. I got first A, B, C. A is 1, B is 3, C is 2. So the number is 132. For budget says for B is 6, for C is 4. Thank you very much. For B is 6, for C is 4. For A is 3. Also tell me both B and C. B is 9 and C is 6. Thank you very much, Oliver. So here is B is going to be 9 and C is going to be 6. So we got all 3-digit numbers. So what is it? A is 1, B is 3, C is 2, 132. Here is A is 2, B is 6, C is 4, which means 264. On the last part, 396 we will get. Yes, we found all 3-digit numbers. I'm happy for that. Okay. 2 more questions, and after that, I'm planning to finish my lesson. Eva says, go teacher. Where can I go, Eva? Okay. And the others? Teacher, what about cases when AB is equal to BA or AC is equal to CA? In these values, how can we do this? AB is equal to BA. A is 1, B is 3, 13. BA 31. AB 26. BA 62. They're not equal. Okay, can I clean it? Everybody? Okay. Question 6 is special question. Irreducible. Okay, question 6. Prove that 12n plus 1 over 30n plus 2 is irreducible. Irreducible means that can be simplified. Okay. Remember the property. Let me find this. I'm looking for my notes. Yes, here. If A over B is irreducible, can be simplified. So we said that greatest common factor of A and B is 1. So, as you remember, A and B have special names. They are called relatively prime numbers. Okay, so when we solve it, greatest common factor of 12 n plus 1 and 30 n plus 2 must be here as 1, right? If greatest common factor of 12n plus 1 and 30n plus 2 is 1, automatically they are relatively prime and we cannot simplify it. So let's say greatest common factor of these numbers is d. If greatest common factor of these numbers is d, we say that d divides both 12n plus 1 and 30n plus 2. 12n plus 1 and 30n plus 2 divisible by d, because greatest common factor. Remember that. And another property, also remember. Here, over here. If n is divisible by d, when we multiply n by a is a number, integer, an is also divisible by d. So, here, when we multiply 12n plus 1 is by 5, d also divides 5 times 12 and plus 1, right? And here, when we multiply the number by 2, still d divides 2 times 30 and plus 2. So we will get here d divides 60 and plus 5, and d divides 60 and plus 4. And another property, remember again, if a and b, they are both divisible by d, so a plus b and a minus b also divisible by d. So I will take difference. D divides 60 and plus 5 minus 60 and plus 4, which means D divides 60 and plus 5 minus 60 and minus 4. So it will be D divides, cancels each other out. 5 minus 4 is 1. D divides 1. What is the value of D? D can be just 1, right? Okay, D can be just 1, because 1 is divisible by itself. So greatest common factor of 12n plus 1 and 30n plus 2 is 1, which means they are relatively and irreducible. Yes. Is there any question? Or does it make any sense? Everything is clear? Do you have any problem? So when we summarize this question, all you need to do is, before prove irreducible, you have to find greatest common factor of 12n plus 1 and 30n plus 2. If you will find for greatest common factor 1, automatically the fraction is irreducible fraction. Okay, let's go for the last question. Let me clean the solution. Just say yes. Okay. Another special question, question 7. $520 divides 1 plus 3 plus 3 squared plus 3 cubed plus 3 to the power of 4 plus, I have to go till 3 to the power of 119, but I don't have any place here. So what can I do for that? Tell me. I have to go till 3 to the power of 119. Give me a favor. Okay, thank you very much. Plus 3 to the power of 119. This number is divisible by 520. Prove it. Before solve it, let's make a brainstorm. Open your brains, ears, everything actually. Focus on it. When you find prime factorization of numbers, for example 12, and what is prime factorization of 12? 3 and 4, right? Okay. Prime factorization of 30, 2, 3, and 2, tell me. 2, 3, and 2, 3, and 5, right? Yeah, 4 is not prime. Thank you. Prime factorization. Yes. Actually, it's 2 square, but instead of 4, we can write is 2 times 2. Here, when we find greatest common factors, greatest common factor of 3, 2, 2, what is it? 1. What is greatest common factor of 2, 3, 5? Is also 1. So it means that when we find prime factorization of numbers, greatest common factor of the numbers must be 1. So 520 is 5, 8, and 13. Greatest common factor of 5, 8, and 13 is also 1. Means that instead of 520, we can write 5 times 8 times 13. 520 is equal to 5 times 8 times 13. It is 40 times 13. Yes. 40 times 13, which means 520, right? Okay. We can multiply 5 and 8. By the way, we can get rid of it. Okay, so on after that, yes, 2 cubed instead of 2 cubed is 8. The number must be divisible by 13, and let's say the number is a, and also 40 divides number a. We will make a group. We will make a group for 13. 13 divides. We will make a group. 1 plus 3 plus 3 square is the first group. 1 plus 3 plus 3 square. And plus 3 cubed times 1 plus 3 plus 3 square. We will make a group here till 3 to the power of 116. 1 plus 3 times 3 plus 3 square. Not 16, 17. Yes, 117. We made a group. Look, 1 plus 3 square 3 cubed times 1 is 3 cubed. 3 cubed times 3 is 3 to the power of 4. We can go till 3 to the power of 119 with the same way. So 13 divides 1 plus 3 square is 13 plus 3 cubed times 13 till plus 3 to the power of 117 times 13. 13 is common factor. 13 is common factor. So 13 divides 13 times 1 plus 3 cubed plus till 3 to the power of 117. By the way, the number a is divisible by 13. I want you to solve divisible by 40. You can prove at home, okay? Is 40 is divisible by 1 plus 3 square till 3 to the power of 119. Please solve it where? At home. And when we finish the lesson, till tomorrow, please rewatch the lesson. Try to think and absorb it. Okay? If you have any problem, I give you my number. You can text me. Okay? Recai Bey, are you there? Can I finish the lesson, if you don't mind? Okay. You're welcome, Mr. Recai. Okay, that's enough for today. So have a nice day. Take care of yourself. I wish you every happiness and success. Bye bye. See you tomorrow.